Hi, today we're doing an overview of 15 Amazon Aurora strategies. Amazon Aurora gives you the performance and availability of a commercial database at a fraction of the cost, but only if you configure it deliberately. Teams that get the most from Aurora treat replication, failover, scaling, and security as deliberate design decisions rather than afterthoughts. This is from systemsarchitect.io blog. Please take a moment to subscribe to our channel and visit the site for more info. Systemsarchitect.io. In this video, we walk through 15 practical strategies ordered from most critical to fine-tuning details, covering resilience across regions, read scaling, recovery, cost control, monitoring, and encryption. Apply them and you get a database that stays online, scales with demand, and protects your data without constant manual effort. 15 Amazon Aurora strategies. 1. Leverage Aurora Global Database for multi-region resilience. 2. Use Aurora Serverless for variable workloads. 3. Optimize read performance with read replicas. 4. Utilize Backtrack for data recovery and testing. 5. Automate failover with cluster endpoints. 6. Multi-AZ deployments for high availability. 7. Optimize storage costs with automatic scaling. 8. Database activity streams for advanced monitoring. 9. Fine-tune performance with query plan management. 10. Data encryption at rest and in transit. 11. AWS IAM for granular access control. 12. Automate maintenance and patching. 13. Comprehensive backup strategies. 14. Optimize performance with advanced configuration settings. 15. Monitor and analyze database performance. 1. Leverage Aurora Global Database for multi-region resilience. An Aurora Global Database runs a single database across multiple AWS regions, with one primary region handling writes, while secondaries serve fast local reads. If an entire region goes down, promote a secondary and keep running with minimal downtime and almost no data loss, thanks to sub-second storage layer replication. For workloads needing strong cross-region consistency, Aurora DSQL offers distributed SkinUAL with 5 nines of availability. Rehearse your regional failover regularly so promoting a secondary stays routine. 2. Use Aurora Serverless for variable workloads. Aurora Serverless automatically adjusts capacity up and down with real demand, ideal for development, testing, and unpredictable spikes. Why does that matter for your bill? Because you pay for what you actually use instead of provisioning for a rare peak. And Aurora DSQL extends the same idea into a fully serverless, distributed SQL engine with very high availability. Set sensible minimum and maximum capacity bounds so cost stays caped while avoiding cold start latency. 3. Optimize read performance with read replicas. Read replicas offload query traffic from the primary, essential for read-heavy apps that would otherwise bottleneck a single writer. Aurora supports up to 15 replicas per cluster sharing the same underlying storage, so the reader endpoint spreads read connections across them automatically and doubles as a failover target. Send reporting and analytics queries to the reader endpoint so they never compete with latency-sensitive writes. 4. Utilize Backtrack for data recovery and testing. Backtrack rewinds an Aurora cluster to a point in time in place without restoring a snapshot into a new cluster. Why does that save you real time? Because you can roll back from a bad migration or accidental delete in minutes, or run a destructive test, backtrack to the prior state, and try again, all without your app changing its connection. Set your backtrack window to comfortably cover the time it would realistically take you to notice an operational error. By the way, this article is a condensed version of the complete article on blog.systemsarchitect.io. See the full blog article and solutions on systemsarchitect.io. Like the video and subscribe to the channel. Check the video notes for links. 5. Automate failover with cluster endpoints. Aurora cluster endpoints abstract away individual instances. The writer endpoint always points at the current primary, and the reader endpoint distributes traffic across replicas. During a failover, Aurora repoints these endpoints automatically, so traffic redirects without you touching a connection string. Never hardcode an instance address that can disappear. Test a forced failover in non-production and confirm your connection pool reconnects cleanly. 6. Multi-AZ deployments for high availability. Deploying an Aurora cluster across multiple availability zones spreads instances over separate data centers, so a zone failure triggers automatic failover to a healthy instance, while the storage layer replicates 6 copies of your data across 3 zones so nothing is lost. This combination of instance failover and zone redundant storage protects against the localized failures that would take down a single zone database. Always place a reader in a different zone than the writer so failover has a healthy target ready. 7. Optimize storage costs with automatic scaling. Aurora storage grows automatically in fine increments up to the service maximum, so you only pay for what you consume with no downtime as volume increases. This is especially valuable for applications with steadily growing datasets, where guessing capacity a year out is nearly impossible. Keep an eye on your storage metrics anyway, since unexpected growth can signal a runaway process or missing archival policy. 8. Database activity streams for advanced monitoring. Database activity streams capture a near real-time feed of queries and connections flowing into Kinesis and from there into CloudWatch or a Lambda function. Security teams use this to detect suspicious access patterns and satisfy audit and compliance needs, since the stream is delivered outside the engine and adds no query load. Route the stream into your existing security pipeline and alert on the patterns that matter. 9. Fine-tune performance with query plan management. 9. Fine-tune performance with query plan management lets you control the execution plans the optimizer chooses, keeping performance predictable even after statistics shift or an engine upgrade. You can capture and lock plans you know perform well, which matters most for critical queries where consistent latency beats optimizer experimentation. Baseline your key query plans before a major upgrade so you can compare behavior afterward. 10. Data encryption at rest and in transit. Aurora encrypts data at rest using keys managed through AWS Key Management Service, covering storage, backups, snapshots, and replicas, while SSL and TLS cover data in transit. Together, these 2 layers are usually a hard requirement for sensitive data and compliance, and managing keys through KMS gives you centralized control and an audit trail. Enable encryption at cluster creation since it cannot be added later, and rotate your keys on a regular schedule. 11. AWS IAM, Identity and Access Management for Granular Access Control. AWS IAM lets you define precisely who can do what with your Aurora resources, down to specific actions and roles, often through short-lived tokens via IAM database authentication instead of static passwords. What keeps a stolen credential from becoming a bigger problem? Least privilege roles do, since each is granted only what it needs, which makes access far easier to audit and revoke. Start from a minimal policy and grant more only as specific needs arise. 12. Automate maintenance and patching. Aurora handles engine patching and maintenance for you, and a maintenance window lets you control when updates land during low traffic periods. The centralized engine lifecycle view shows which versions are supported so you can plan upgrades before end of support. This removes manual toil and the risk of falling behind on security fixes, and disruption stays small since Aurora coordinates changes across the cluster. 13. Comprehensive backup strategies. A solid backup strategy combines Aurora's continuous automated backups stored in Amazon S3 with manual snapshots taken at meaningful milestones. Copying snapshots to another region gives you a recovery option that survives a regional problem and helps satisfy disaster recovery requirements. Testing your restores is the most important habit here. A backup you've never restored is only a hope, not a guarantee. 14. Optimize performance with advanced configuration settings. Beyond the defaults, Aurora lets you tune instance class, memory, and cache settings to match your workload, so you get the CPU and memory your queries need without paying for unused capacity. Connection pooling, often through RDS Proxy, keeps a flood of application connections from overwhelming the database. These settings interact, so changes are best made one at a time with measurement in between. Use performance insights and CloudWatch metrics to guide each adjustment. 15. Monitor and analyze database performance. Continuous monitoring turns a database from a black box into a system you understand and can improve. CloudWatch tracks core metrics like CPU utilization, IOPS, and connection counts, while Performance Insights shows which queries and weights actually consume your database's time, letting you spot a bottleneck before it becomes an outage, and pinpoint the exact query responsible. Review these trends regularly so your optimization work stays proactive, addressing problems while they're still small. Amazon Aurora rewards teams that design for resilience and scale from the start. Across these 15 strategies, you've seen how to survive regional and zone failures, scale reads, and recover fast with Backtrack and tested backups, while encryption, IAM, automated maintenance, and continuous monitoring keep it secure and current. None of this requires heroic effort, but together it adds up to a database that's reliable, secure, and cost-effective. Start with the critical items, build the monitoring that tells you how you're doing, and layer in the rest as your workload grows. Thanks for checking out this video. Hope you liked it and subscribe to the channel. Find a lot more articles and guides both on systemsarchitect.io and codeguides.io. Again, that's systemsarchitect.io and codeguides.io.